So here's the help video for quiz 1.13. Alright, it says how many lines of symmetry does a regular pentagon have? Alright, you don't need this picture right here, but I went ahead and put it in because I know some of you are very visual. So we're going to actually draw the lines on this one. Okay, remember a line of symmetry is somewhere that you can fold it in half and it would be the same on both sides. So for example, if you folded your paper, I know this line isn't perfect, but along that line, then it would map onto itself. It would lie back on top of itself. So that's one line of symmetry. We could do the same thing this way. We could fold it right there. We could fold it here. We could fold it here. Well, I'm not drawing these lines very straight, but we could fold it at all of those places, and I really should have color-coded these so it was easier to count how many we have. We have 1, 2, 3, 4, 5. Okay, so a regular pentagon has 5 lines of symmetry. Now y'all are not going to want to get a picture and draw those lines every time. Here's the deal. Anytime you have a regular polygon, it's going to have the same amount of lines of symmetry as it does sides. So that's a super awesome shortcut. Anytime the polygon is regular, and remember regular means all the sides are equal and all the interior angles are equal, then however many sides it has is going to be how many lines of symmetry it has. Alright, this one says, which line is the line of symmetry in this rectangle? So again, we're looking for a place where we could fold it and both sides would line up perfectly. They would map back onto themselves. If we folded it across the diagonal, we would end up with like a part of the rectangle. This part would be up top. It just wouldn't line up. If we folded it along P, there'd be nothing over here. So the only one that works is if we folded a line along line N. Then this side would match up or line up with that side. So the line of symmetry here is line N. Which figure has exactly 4 lines of symmetry? Okay, again, you don't need these pictures if you can remember the shortcut. For any regular polygon, you're going to have the same amount of lines of symmetry as you do sides. So a square is a regular polygon with 4 sides. That means it has 4 lines of symmetry. A hexagon has 6 sides, so it would have 6 lines of symmetry. An equilateral triangle has 3 sides, it would have 3 lines of symmetry. An isosceles triangle is different. That is not a regular polygon. Remember, regular means all the side lengths have to be the same. And in an isosceles triangle, only 2 sides are the same. So it only has 1 line of symmetry. But this one wants to know which one has exactly 4, so it would be a square. Which figure has reflexive symmetry? In other words, which one can we fold across a line of symmetry and have it map back onto itself? And it doesn't tell you which way the line of symmetry has to be, so it could be, horizontal, vertical, diagonal, whatever. In this case, we have a line of symmetry right there. If we folded it right there, both sides would map onto each other. None of the other figures have a place that you could draw that line of symmetry to make it work. Select all the polygons that have reflexive symmetry. Alright, so let's go through each of these. The first one, it looks like if I draw a vertical line, that would be a line of symmetry. So that one works. Same thing here. It looks like I could draw a vertical line and it would map back onto itself. So that one would work. Has a line of symmetry. A vertical line definitely wouldn't work here. A horizontal line wouldn't work. A diagonal wouldn't work. There's nowhere that I could draw a line to make that fold onto itself or to map onto itself. So that one does not have reflexive symmetry. Let's check this one. If we did a vertical line, it wouldn't work. Horizontal would not work. Diagonals, nothing's going to work here either. So the first 2 are the polygons that have reflexive symmetry. Good luck on your quiz!